Okay, welcome you all to the basic course in data science using statistics. Now, before I start this course, let me first introduce myself to you. I am Mr. Bishwadeep Basu Malik, an assistant professor in the Department of Basic Science at Institute of Engineering and Management, Kolkata. Now, I will be taking one of the modules of this very interesting course of data science using statistics. So let's first discuss, before I start with the concepts of probability theory, which I think is a very essential part of data science. I must discuss that what are the topics that I'm going to cover in this particular course, and what are the basic course outcomes, and why do you think that probability is necessary for learning data science. So let's start right away. First, we move on to the concept of the topics to be covered. So first we try to discuss that what are the topics to be covered. So we first start with the first topic that we are going to cover in this course in theory of probability are some basic terminologies related to that. So that is very, very important, because before we go into the concept of probability and its definition and all, okay, we must know some basic terminologies. So that's what we are going to first cover. And once we are done with that, then we'll come to the classical definition of probability. That's absolutely very essential, because if you don't know what is the classical definition of probability, you may not be able to find out the solutions to the probability problems. So after going to the classical definition of probability, we will now then go to one of the the most important rules of probability, which we call it as the general addition rule of probability. And this rule is very much used in most of the problems of probability. So we have to master this particular rule. Then we come to the conditional probability, another very, very important aspect of theory of probability. So we'll actually give the concept of conditional probability, that when we are using the conditional probability, at what situation that we are using it. We'll discuss all those things over there. And then we come to one of the most important theorems of theory of probability, which we call by the name of Bayes theorem. So this is a very important theorem of probability, and it is what you can say one of the applications of conditional probability, and is applied to a certain particular situation. So you must know that when we are using it, the concept of Bayes theorem, then it's absolutely very, very essential in theory of probability. And then we come to the independent events. Okay, so what is the concept of that two events are independent? So that you must also know that what is the condition that the two events are independent, or when do we actually use the concept of independent events in solving a problem of probability. And finally, we'll be ending the course with some applications of probability, which you must know, because in theory of probability, the best thing is that you have to solve problems. Unless you solve the problems of probability, you won't be able to master it, because knowing the concept and then not able to apply in solving the problems will make no use of this particular course. So you must know how to solve the problems of probability by knowing those rules and the theorems that we will discuss here. So before we start, this course is not for everybody, but yes, it's for those who want to learn probability actually. But there are some course prerequisites, so you must be aware of that. And I hope that the learners here must be very good in the first prerequisite, which I think is set theory. Because if you are not good in set theory, you don't know the concept of set theory, it may find it very difficult to understand the lecture of probability, which I'll give one after the other. And the second most important thing, I think, to understand the theory of probability is permutations and combinations. This permutation and combination is another very important thing, and unless you are good at the concepts of permutation and combinations, you might find it quite difficult to solve the problems of probability at the later stages. So before we start the course, I hope that all of you have gone through these two topics of set theory and permutations and combinations. So if you are not, I'll say that you must go through it, and before you go to my first lecture, right? Now, as I was telling you that what are the course outcomes, so we'll just discuss some of the course outcomes, because what do you expect from this course of probability theory, which I will discuss over here. So the first outcome that you can expect now, since this course is basically related to the data science, so I'm just telling you that one of the outcomes that you can expect, that after this course, when you are thorough with the concept of probability, you will surely be able to apply those concepts in problems of data science, because you see data science is mainly based on statistics and probability. So if you are good at probability, then only you'll be able to tackle the problems of data science. So this course will hopefully help you to achieve that particular goal. Then the second thing is that you will be understanding the probability for data analysis. That is one of the most important part of data science, that is how to analyze the data. So in those situations, we quite often require the concept of probability, and so if you master this concept of probability from this particular course, you'll be able to do that for data analysis. So that is the second outcome that you can expect from this course. The third outcome that you can expect from the course is the most important thing, that is you'll understand the fundamentals of probability and various probability rules that help one to measure uncertainty. That's a very important thing. You can expect to get or find out what is actually uncertainty is, because if you don't know what is an uncertainty, then it's no use of learning this course in probability. So that once you know that how to measure uncertainty which is involved before making those important decisions. The decisions are very, very important because this probability actually leads to finding some decisions, because if you are not able to find those decisions, then learning this course has no use. So therefore this course will actually give you to master those fundamental concepts of probability and its various rules, so that you can measure uncertainty, and therefore you can apply those uncertainty in making those very, very important decisions in data science. Then lastly, you can perform several analysis with respect to business decision involving uncertainty. That means knowing this theory of probability, you will be able to make several analysis, because analysis is a very important part of this data science. So unless you are able to analyze those various types of problems, and while analyzing, you will see that you will encounter the situation of probability, and therefore if you are thorough at the knowledge of theory of probability, you will be able to analyze those particular problems, and will be able to make a very good business decision, which is obviously involving uncertainty, because uncertainty is basically what is probabilities mean. So these are basically the four course outcome which you can expect after learning this course, and I hope it will be a very good learning experience for all the learners. Now the most important thing, that yes, what is it essential to learn probability? Why is it essential? Why is it essential to learn probability? Now that is very, very important. That you must be thinking that why I should learn probability for data science. Okay. Now the first thing is that it helps you to make better decisions from analysis of data, because if you are good at theory of probability, that will actually help you to make better decisions, because probability helps you to make good decisions. Okay, so if you are good at the concept of probability, you'll be able to make good decisions from the analysis of data, because data analysis is a very important part of data science. Then in the context of data science, statistical inference are used to analyze and predict trends from data, and these inferences use the concept of probability. That's a very important part. You see, the statistical inference, that is drawing conclusion on a particular statistical analysis, okay, that involves a huge concept of probability. So unless you are good at probability, you may not be able to draw inferences on statistical analysis. So in that context, which is a very important part of data science, you must know the concept of probability. So that's absolutely important. Then we come to the third important essential part of why you should learn probability for data science is that it helps us to understand various machine learning algorithms at a fundamental level. You know, machine learning is an integral part of data science, and while going through the machine learning algorithms, you'll see that some of the algorithms require a lot of concept of theory of probability at a fundamental level. So if you're not good at probability, you may not be able to understand those algorithms, and hence you may not be able to apply those algorithms in solving the real life problems of data science. So that's why you need to know probability. Now the fourth point I think is that it helps us to interpret results obtained in order to fit a model to explain the real world data much better. So knowing theory of probability, it will actually help you to interpret the results. Okay, that means you are able to make an analysis of the results. So one person knowing probability and one person not knowing probability will face difficulty in interpreting the result. And interpreting the result for what? In order to fit a model to explain the real world data. Okay, so you are fitting a model to a particular set of data, and to fit that particular model and to explain it or interpret the results, okay, if you are good at probability, you'll be easily able to do that. So that's one of the important essential point to that why you should learn probability for data science. And lastly, you know that data science involves a lot of statistics, so you'll see as the course progresses, because you see that there's a lot of statistics in data science, and those statistics, to understand those statistics, it requires a lot of probability, because they are based on the probabilistic model. So unless you are good at probability, how will you understand the probabilistic model? So the probabilistic models are very important to learn the statistics, which is essential for a part of our data science, right? So these are the points which I think are makes up the thing that why it is essential to learn probability for data science. Okay, so now having said that, now we come to the concepts of probability right away. So as I told you that I'll be starting with the basic concepts of probability. So I first start with a very basic concept which is called as random experiment. This is the most important part in theory of probability, because the theory of probability is entirely based on this term which we see on the screen, which is called random experiment. Now what is a random experiment? Now you must wonder, all of you know that what is an experiment. I think all of you know what is an experiment, but those who have gone through probability earlier might be knowing this word random. Why you must be wondering why this word random is attached before the word experiment. So I'll just explain that why an experiment is called a random experiment. So first I would say that all of you know what is an experiment, because first you must be clear with that, because if you are clear with what is an experiment, I think all of you know that what is an experiment, then only you'll be able to understand what is a random experiment. So what is an experiment? I think all of you know that in simple words, an experiment is a procedure to determine some results or outcomes. As simple as that. Because an experiment is basically a method or procedure that you apply, and by which you have a desired some results or outcomes. Unless there are some results or outcomes, it's not considered to be an experiment. Now a very similar thing happens here, but not exactly what we are saying it over here. I'll tell you that why it is called a random experiment now. Now I will actually take a very simple example to demonstrate, two examples in fact I'll be taking it, to demonstrate this concept of this random experiment, which I think is the most important aspect of theory of probability. So yes, that's the question comes, that can an experiment be random? That's what I'm asking, that why we call an experiment to be random. Then what's the word random actually attached before the word experiment? So that's the question that should be coming into your mind right now. So as I was telling you that I'll be just taking one example. So let's take one example, a very simple example actually, and you can see the example that I've taken here is that we have considered an experiment of tossing a coin. So I have considered an experiment of tossing a coin, right? And it's a very simple experiment, you know. And then why do you call this is an experiment? Because if you toss a coin, you have some results or outcomes which you all know, and therefore it can be classified as a experiment, which we have already discussed here. An experiment is a procedure to determine some results or outcomes. So if you consider an experiment of tossing a coin, you see the first thing, the two things we observe. Okay, that's very absolutely clear. What are the two things we observe? The first thing that we observe is that we can predict all possible outcomes before it is performed. So what are the outcomes that we can predict before we toss the coin? we're able to predict that what are the possible outcomes. And all of you know that, because if you toss a coin, before you toss a coin, if I ask you the question that what are the possible outcomes, so you'll be able to say the possible outcomes are head or tail. Okay, so there are two possible outcomes basically, and you won't get anything apart from this. I'm talking of unbiased coin or a biased coin, right? So we can predict all possible outcomes before it is performed, and they are head and tail. And the second point we observe is that we are not able to predict that whether the head or maybe tail also will come surely in the first toss. That is what we can't predict. Let's say I'm tossing a coin. Now, can you tell me that you are going to get a head in the first toss surely with 100% surety? No, we can't say that. You may get a tail, you may get a head also. There's no problem. But that's you are not sure of that. Since you are not sure of that, okay, you are unable to predict. It becomes a non-deterministic situation. It's not a deterministic situation. Okay, try to understand this point very clear, because you know the two possible outcomes, head and tail. Now you have tossed the coin, right? So you have tossed the coin, and on tossing the coin, you are asked to say what is the outcome. Now you will never be able to say with surety that yes, I am going to get a head in the first toss, or let's say if I am going to get a tail definitely in the first toss. Nobody can say like that. Okay, so you are unable to predict the particular performance of the experiment. Okay, so that is what you can't do. So these are the two observations that we can see while we perform this experiment of tossing a coin. So the first thing that we see is that we are able to predict all possible outcomes. Secondly, we are seeing that we are not able to predict that a particular outcome that we know is going to come on a particular performance of the experiment. That we are not able to do. Now, let's take another example. Okay, very common. These are very common examples. The tossing of a coin, and you see, I've taken the example of rolling of a die. You see, rolling of a die. So when you know what a die is, I hope a die is basically a cube, basically, which has 6 faces, and they're marked 1, 2, 3, 4, 5, 6. Mainly used for some board games and all. So you're asked to roll a die. Now, when we are rolling a die, is it an experiment? Surely it is, because it's a procedure by which we get outcome. Because when we roll a die, there's an outcome, and therefore on the basis of the outcome, we actually play the board game, or we make the next moves, right? So in the case of rolling a die, also you'll find there are two similar type of observations that we have seen in the case of tossing a coin. So what are those? Firstly, we can predict all possible outcomes before it is performed, and they are 1, 2, 3, 4, 5, 6. Just like in the same way, we were able to predict all possible outcomes in the case of tossing a coin, which was head and tail. We are able to predict all possible outcomes of rolling a die, and they are obviously 1, 2, 3, 4, 5, 6. These are the 6 outcomes that you can expect to get if you roll a die. You should not get anything beyond that. I'm talking of unbiased die, of course. And the second point is that, like in the same way that we have discussed in the previous example of tossing a coin, we are not able to predict with certainty that we will get a 6 or maybe any of the remaining 5 outcomes. And nobody can say that. I mean, if you roll a die, you will not be able to say with surety, yes, I'm going to get a 6 in the first throw. No, we can't say that. Okay, neither you will be able to predict, yes, I'm going to get a 3 in the first throw. No, you may get a 4, you may get a 5, you may get a 3 also, but you're not sure about that. Surety factor is not there. That means you are not able to predict with 100% surety. That is, it's a non-deterministic situation. So you see, these 2 points are observed as common to both the experiments. In the case of tossing a coin, we found that we are able to predict all possible outcomes, and secondly, we were not able to predict out of the outcomes that we know, which outcome is going to occur at any particular performance of the experiment. And in the same case, same 2 observations that we find in the case of rolling of a die. Now, that's what I have written over here. In both the above 2 examples, 2 things are common. as I was telling you, that we know a priori the set of all different possible results or outcomes. That's what I was telling you, that we are able to predict that what are the possible outcomes of this experiment. And secondly, we are not able to predict. That's why we call it impossible. It's impossible to predict. In fact, impossible to predict which of these outcomes will occur at any particular performance of the experiment. So you see, these are the two important observations that we get out of this particular experiment, right? Now, such class of experiments are called random experiments. So this class, now these two experiments belongs to a certain class. It is not of an ordinary experiment, okay, where you observe these two important characteristic. So if you observe these two characteristic in a class of experiment, those class of experiments are called random experiment. Then what is the word random here? The word random means, as I was telling you, that unable to predict or non-deterministic. That was the second point, that is, you are not able to predict a situation, that is what is the outcome of a particular performance of the experiment. That means it is a non-deterministic situation. It's not a deterministic situation because you are not able to predict it. So something which you are not able to predict, or something which is non-deterministic, is called as random. And therefore these types of experiments, that is tossing a coin or rolling a die, or there are a lot of examples. Actually, the entire theory of probability is based on these random experiments. Drawing a card from a full pack of playing cards, these are very common examples. That's why I'm taking those two to explain this term. So those class of experiments where you find these two characteristics are called random experiments. The word random meaning unable to predict. You're not able to predict. That is a situation that we have got is something non-deterministic. So examples, as I was telling you, the two examples I have taken: tossing a coin and rolling a die, that we have seen. And the third example I've added here, drawing a card from a full pack of playing cards. Okay, so that is also a random experiment, because when you are drawing a card from a full pack of playing cards, you have 52 possible outcomes, because you all know a pack of playing cards has 52 cards. And in second point is also true, because you are not able to predict that which one of those 52 outcomes is going to come in the first draw. Like, you will not be able to say that I'm going to get a queen of spades if I draw a card from a full pack of playing cards. So it's not possible for you to say that. And as such, the situation becomes non-deterministic, and this being an experiment is classified under the term called random experiments. So random experiments are those where we know all possible outcomes of the experiment before it is being performed. And the second point, most important, out of those outcomes that you know, you are not able to predict that which one is going to occur at any particular performance of the experiment. So such experiments are given the term random experiments. And in mathematical theory of probability, it is normally denoted by the alphabet capital E. Okay, so this is what is we use actually. We use the term capital E to denote our random experiment. So that's all for today's class. So we'll be discussing of this theory of we'll be discussing this theory of probability further in the next class. We'll be coming into the concept of events and different types of events and further concept of probability in the next class. So that's all for today. Thank you very much.